Hello everybody, we're going to be working on the second set of exercises today from Unit 1, which is Chapter 14, and these will be the exercises we will be completing. So 14, 12, 17, 18, and 21. And I am recording this video because I realized that I've never recorded the even number exercises for this. And as part of, kind of the help in getting you guys to do this work, I thought it was a good idea to do that. I think people enjoy the videos more than maybe just looking at a solved version of the code. I am going to be working in Eclipse today, which is pretty normal for at least the early parts of this course. And so I'm going to go ahead and launch my tool here. On my other screen, I will be launching my personal cheat sheets, which you guys don't get to see. Right? Sometimes you think I'm brilliantly coding off the top of my head, but sometimes I'm actually looking at my answer from last semester. And I'm also going to be pulling the textbook up on the screen to follow along with. And for those of you that are watching these videos maybe for the first time, I always like to just reiterate that we use Daniel Liang's book, Liang, who is an Australian author. If you guys ever watch any of his videos online, I'm going to probably guess, probably not. He's interesting because he's a Oriental guy with an Australian accent, so it's a very interesting, unique accent. But he's a brilliant author, and he has, I think, one of the best Java books out there. And he often is quite amusing if you do watch those videos. So, okay, I'm getting my stuff together here. And make sure that you have whatever coding tool you have open. And you can see I have Eclipse open on my screen here. All right, I pulled the book up on the screen so we can look at the exercises that we're working on. And the first exercise that we're going to work on is 14:12. And I want you to notice that some of his exercises, and usually there will be the even numbered ones, will always have the solutions provided. And in our course shell, by the way, I do have on the resources page a zip file with all the solutions to all the even-numbered exercises, which I do on occasion assign, by the way, because I think they're good examples. He does have a video note on this particular exercise. And, in previous versions of the class, I have actually played that video, mostly to get a kick out of his Australian accent. And to see how he proceeds on writing the code, and to show you that people can have different approaches. So he approaches the problems a little bit differently than I do, but we kind of both end up in the same place. But let's read this here and see what we have to do. It says, display a bar chart. Write a program that uses a bar chart to display the percentages of the overall grade represented by projects, quizzes, midterms exams, and the final exam, as shown in figure 1446b, which I think is right here. So this is basically what we're trying to create. And it's hard to tell from this black and white image, but these are actually different colors. And so we'll have the option to choose the colors, but we will create these objects on the screen, and we will also create the labels that describe them. And we're also going to use a little bit of math to make sure that the relative heights of these bar charts are correct proportionally and visually. All right. Suppose that the projects take 20%, are displayed in red, quizzes are 10%, displayed in blue, midterms are 30% and displayed in green, and the final is 40% and displayed in orange. And then it says use a specific class, the rectangle class, to display the bars, and interested readers may explore the JavaFX bar chart for further study. So if you want to look at this, class, there's actually a class that they have built into it, and many programming languages have this, by the way, that help you to automatically create these things rather than manually program the way we are about to do them. However, it's important to learn the principles of what we're doing so that you can apply them to various different types of problems, and the fact that we're going to pull math into the situation too is going to kind of lend a little bit of clarity as to how we do things proportionally, and to show you that really the tools that are seemingly automatic are actually kind of simplistic under the hood, and you can kind of create your own when it comes down to it. All right, I'm pulling up my cheat sheets here on my other screen, and please remember, if you have any questions along the way, just speak up, turn on your mics. Your faces are not recorded, but your voices will be. So if you have a barking dog, please keep your mic muted, or a crying child, or whatever it might happen to be. All right, we're going to begin with doing some of the basics here. So we're going to go over to Eclipse and actually just get our our project started, and that's not Eclipse. This is Eclipse. And I'm going to begin by closing any of the work that I have open. Now currently, I have a project in my Package Explorer named Chapter 14, and this is where I put the first set of exercises. And I did have a number of questions from people when they were turning in work. Hey, I didn't realize I should make every exercise a separate project. Next time I'm going to put them all together. And here's the real answer as to what you want to do here. My thinking is that each set of exercises is probably best as a separate project. It just makes it easier to zip them and keep them separate for your own purpose. So I'm not going to create my new Chapter 14 exercises here. I instead am going to create a new Java project, and I'm going to label it accordingly so I know what's in here. So I'm actually going to say Chapter 14 Part 2. And I'm just going to click Finish. And then you will see a new project has been created. Now on top of this project here in the Package Explorer, I'm going to right click and create a new class as per normal. And we're going to call this exercise 14_12. And I'm going to go ahead and add our main method. Just a reminder, if you do have something in the package declaration area, if you declare one now, then you're going to have to do it for everything in the project. My advice is to keep it blank. If you wonder at all why we have that, it is not unusual for an application to actually have many separate programs working together to create one. And in that case, then you package them. None of these will be working in that capacity, so not really necessary. We'll begin by extending to the application class, so we'll pull in the superclass. It will highlight red. We'll do the control space trick in Eclipse to bring in the right Java FX library. Now it will recognize that we need our primary stage, so we are going to add the unimplemented methods by simply hovering over the red underline of the class title. And then I'm a huge fan of moving the main method to the bottom. That's just kind of my work habit. I noticed that the author does the same thing, although I see other notebooks and authors doing it the other way around. Either way is fine. And then I'm going to put in the launch directive immediately so that whenever I go to run this, it will just automatically run. All right. I'm going to delete some of the blank lines here and also get rid of these unnecessary comments. No reason for them, really, so why have them? All right. Next thing I'm going to do is I'm going to start thinking about how I'm going to approach this problem. And that's probably like the most challenging aspect of this is how am I going to create this? It told us sort of that we need to use the rectangle class. So that's one thing that we're going to have to do. And in fact, as I think about that and I look back at the book, I'm trying to get to the PDF, I noticed that I'm going to have 4 rectangles I'm going to have to create. And the way that my brain thinks is, you know what, I know I have to create 4 rectangles. I may as well go ahead and pre-create them. So let's do that preliminary step. But one other thing that some of you might be thinking is, and the other stuff that he did, he's always copying the stage and the scene and all that, as I always say in every video. And so we might want to be smart and go back to one of our older applications and grab those components because you know what, we're going to have them anyhow, one way or the other. So let's grab those repeating 4 lines from a different application and pull them into the current one and place them at the bottom of the start method. All right. Now this is pre-configured with some values that are of course are going to underline red because I haven't created these things. But one thing we can change right off the bat is the title that's going to be up in the title bar of the application. So this is going to be exercise 1412, which displays a bar chart. And you can put in here whatever you want. I'm not really grading on what you put in the title. I always like to be verbose and descriptive if possible. All right, now that we have that in place, let's go ahead and start creating these rectangles. And the first thing that we can think about is, well, we know we have to use the rectangle class because, frankly, the book told us to. So I'm just going to type the rectangle class name, and notice it's with a capital R. that will flag red, and I will control space to pull in the correct library. Now notice the first library is not the one we want to use. We want to stick with the Java effects library. Some people will ask me, Ty, what would happen if I pulled in a swing or an AWT component? Would it still work? And the answer to that is yes. You can actually mix the two graphical formats. But the general rule of thumb is if you're using Java effects, stick with Java effects. Now I'm going to be creating 4 rectangles, so I'm going to call the first one just R1 for rectangle 1, and then just say new rectangle, spelled correctly of course. So I'm going to get my typing fingers going here, with parens and semicolon. I am going to come back at some point and add some parameters here, but not at the moment. First I just want to make the rectangles. So this is going to be a repetitive process, so you can just copy and paste 3 times more, and then come back and just change the rectangle names to sequential numbers. And you can name them really anything you want. Just name them something that you will recognize. And for me, this is a simple enough program where R1, R2, R3, R4 is perfect. Okay. The other thing that we were told is that we were going to be given very specific colors to apply to these, and you know, in fact, I'm going to create a little extra space in between each one of these, and I'm like, hey, the color is an easy thing to do once you've created the rectangle, even though we might not have named it yet. But I do know from reading the exercise that we're going to do project, quiz, midterm, and final, and the colors for those respectively are red, blue, green, and orange. And I'm just going to determine in advance, this is R1, R2, R3, R4, and what you might want to do if you want to be more verbose and descriptive, you could say, you know, rectangle project, rectangle quiz, etc., etc. You can name it any way you want, but ultimately up to you how you choose to do that. So I'm going to begin remembering red, blue, green, orange, and in fact I'm going to cheat and go red, green, blue, orange, you know, and I didn't even put commas in between. I just want to remember that sequence because that's what we were told to do. Coloring them is really a piece of cake, and this is kind of fun because you can just call the object by name and describe this command, which is a method called fill, and then we will include inside of the parameter the color we want to call it. And so you do that with the color command, which is a class, by the way. So it has to start with a C, capital C, and then the color name in all caps. All right. You will notice right away that it automatically added the color class up above. I didn't do a darn thing. Just by choosing it from the drop-down list, it automatically populated the import. If for some reason, if your color is not automatically adding the library, just hover and choose from the menu, or go to the end of the highlighted word in red and do the control space trick to pull it in, or I guess you can type it by hand too. Now this is going to be a repeat process again, and I'm a big fan of not mistyping, so I'm copy pasting and just changing simple parameters. So this one's going to be blue, this is going to be green. Don't forget to change the rectangle number. And then finally this one's going to be number 4 and orange. Alright, so that's the coloring part is done. So this little tip that I had here, I'm going to erase now. The next thing I want to kind of try to remember are some of these percentages. So it's like 20, 10, 30, 40. So I'm just going to write that here. 20, what was that? See, I forgot already. 20, 10, 30, 40. 20, 10, 30, 40. And that respectively will apply to each one of these rectangles. That way I don't have to bounce back and forth too much. The other thing that is helpful is to know that the first one was project, quiz, midterm, and final. So that's project. This is quiz. This is midterm. And this is final. And this is just a cheat sheet for me. All right. Now, as we look at this, we also realize that with each rectangle is going to be a little label that sits above the rectangle. And each one of those labels, notice it's not at the bottom, so it's like really easy to place them all in a row. And they're not at the top, once again, easy to place in a row. They're all relative to the position of the height of the rectangle that's created. And then the trick becomes, okay, well, how do I get the rectangle the height it needs to be? So that's what we're going to work on next. So let's talk about that for a second. When we work with the rectangle class, and you notice that I'm hovering over the term in the code, and Eclipse will pull in the Java doc, sort of. And notice how it says in that little box in the corner, press F2 for focus. So if I hit F2 on my keyboard, it will expand the Java doc, and in fact I can just open it larger. Or I can even take it one step further and open the actual Java doc in a browser window. And this is kind of interesting about Eclipse. It's got a built-in browser, folks, right? So when you're doing web work, you can just look at it right there. But what the Java doc is telling us is all about the class, and more importantly, all the parameters that we can feed it, and including all the overloaded ones as well. So in other words, we can either create the rectangle empty, which we did. We have the option of sending 2 parameters, the width and the height, or 3 parameters, the width, the height, and the fill. So I could have just done the color right inside of the parameters, but I did it a different way. And then maybe this one might be pertinent too. In fact, this will be the one that we use because we have the X and the Y, the positioning element, and then also the width and the height. So we can position it and give it a height all at the same time. And so let's use this and notice kind of the breakdown of this. And this is why the Java docs are helpful, you guys. When you're working with parameters that you, or classes you just don't remember. And here's the little clue. You're not going to remember any of this stuff unless you're doing it all the time. And so you got to be in the position to know how to look it up quickly when you're presented with the issue. And so that's what I'm doing here is I'm looking it up. So it's X and Y, and then width and height. And if you remember, X is the across pixel measurement. So we start at 0 on the left and then count up. And then Y is the vertical, starting at 0 at the top of the screen and counting down. And then the width and height in pixels in that order. Okay, so it's across, down, and down is kind of the way I think of it, or a horizontal, and vertical. Just whatever it takes for you to remember it. And if you don't remember it, then you just look it up just like this, like I did. And so what I would then place into my code, going X, Y with height. So I might even put a little cheat sheet up here and say X, comma, Y, comma, width, comma, height, just for example. And I'm not even looking to spell it right. I'm just doing that to remember, okay? Just a little cheat sheet for myself. Now, as I look at the book and look at this graphic, first I'm noticing that the window is a certain width and height, right? So it seems to be much wider than it is tall. And so I'm going to speculate a little bit on how wide it is, but my rough guess is that it's roughly twice as wide as it is tall. That's what I'm seeing on the screen. And it might be actually a little bit wider than twice as wide as tall, but I'm just going to pick some numbers and drop them in here. And I'm always working ultimately from a set of variables that I'm controlling. And ultimately what I did last time is I set my width to 500 pixels just to give myself plenty of space. And then I also started working here to speculate, well, all right, if that's what the width is, then the height should be about half, right? But what if the person is changing the window? And then I thought, well, how do I make sure that the height of the boxes are correct relative to each other? And then one of the answers to that is to actually probe the height of the object, like in other words, preset it and calculate against it. Now, so in other words, I could put in a value here, for example, of 250. which was about what I would speculate. And then I might decide, well, that's not going to work either, because maybe it should be a little bit more, because that was kind of my guess, right? A little bit more than that. But what if the person is changing it? So let's say the person grabs the bottom corner of the window and drags it and makes it bigger. And so if I'm calculating relative to the height, then the height changes, then all the perspectives are off. And so I'm going to use actually a different kind of trick here. I'm going to put a variable in this place, but before I do that, I'm going to create a couple variables up here at the top. Both of them will be doubles, and the reason I'm doing this is because the parameters that the rectangle takes are also doubles if you paid attention. So I want to make sure that I stick with that. So the first one I'm going to create is just a height variable, and I'm going to preset that to 300, which stands for 300 pixels. I'm also going to create another variable called pane height, and the reason I'm doing that is to give me another point of reference from which I can do some math to determine the percentage correctly, and I'll show you as we go. And this one I'm going to preset for half the value, and you'll see the logic as we proceed, hopefully. Now the other thing that I'm noticing is if I took this parameter out, I have to have something here. And so what I'm actually going to have here is a pane height. And really what's going to happen is the pane height will be what's visible to us, but the height is going to be relative to the object. And let me explain what I mean by that. If you look at this graphic, you'll notice that this might be correct relative in height to midterm, but certainly this height is not 40% of the height of this window. And so what I'm really doing is I'm setting a height that's taller than the window so that all of these will size against that taller height, but will allow for the window to be shrunk down a little bit so that it fits relative to the space we have. All right, now, I don't know if that makes sense mathematically, but I assure you that if you do the math on it and you do a little bit of subtraction is really the key, and then a little bit of a multiplier, and then you can kind of adjust the window anywhere you want, and it'll kind of look good either way, is the goal. This is something you might not intuitively guess. So a lot of people, different from the approach that I'm using here, by the way, will opt to hard code the values into the parameters. And ultimately that's okay as long as it works out. It's when people start adjusting the window that it might give you some problems. All right, so let's take a look at how we're going to proceed here by putting parameters in. So the first two values are the x and the y. Relative to this graphic, 0, 0 is up here in this corner. And so we need to place this rectangle, and we place it relative to the top of this corner is the starting point for the rectangle relative to the xy. And so we have to figure out how far down we're going to come in order to do that. Now, the horizontal placement is pretty easy, honestly, because if you think about it, we can see this is not touching the edge of the screen. And I'm just going to speculate that that's about 10 pixels in the x dimension. So the first parameter, which is x, I'm just going to set at 10 pixels. I'm just speculating, and actually I'm cheating because I'm looking at my solution from last year. The next parameter is going to be the y position, which is now going to get to be a little bit trickier. So here's what I'm going to do. I'm going to actually do a little bit of math. I'm going to take the pane height, which I've preset at 150. I'm going to subtract from it the height of the relative container that I'm imaginarily creating, and, excuse me, I'm going to multiply that height by 2, and actually 0.2, which is the 20%, and maybe it's better to list it like this, because it's going to be, the height is going to be relative to the height of the pane. All right, and so just to explain once again, we're going to take the pane height and subtract 20% of the height from it in order to determine the y position. So let me just kind of make an illustration for you which might help to clarify this. So if I'm creating, and here I'll pull up my little drawing tools here, a container that, if you can imagine, is I'm trying to figure out what 20% would look like. You know, it's like this tall. I'm multiplying this and figuring out what 20% of this height is. And that would probably figure out, you know, from the relative to the top, it would be about this much. And so what we're going to do is we're going to set the Y position relative to the height of the pane minus that 20% so that we end up here to start with. And I know that's kind of like a big rigmarole to get there. And that's just to get the starting point. Okay, so we're doing it mathematically rather than deciding this is where it's going. Okay, so code-wise, that looks like what I have in my code now. So the pane height minus 20% of the height. All right, the next things we have to put in are the width and the height. So those are going to be done a little bit differently. First of all, the width looks like something to me that will be consistent from object to object. And you know what? If this is 10 pixels right here, I'm going to speculate that this is 100 pixels wide. So that's the number I'm just going to go with and run with it. And everything will kind of be relative to that. So it's going to be 100 pixels wide. And now I need to determine the height. Well, the height is going to be 20% of the height so that it scales correctly. So we're just going to say height times 0.2. All right. Now that is enough to actually get this rectangle on the screen. Okay. So how do we actually see it? We could actually run the program now and hopefully see what we're seeing. But you'll notice that in the scene, we still have an unnamed pane. And we haven't decided what kind of object we're going to throw this into. One thing that the author does in his video is he introduces a new thing which is called a group. And this is something, you know, I'm not a huge user of this particular class, but there's some advantages to this because when you group things together, they become related in the application and therefore makes it easy for you to do things collectively to the group, which is kind of his design. You'll notice it's flagging red, so I'm going to hover. And I'm going to import the group for Java FX Scene. And this is a grouping element that allows you to put stuff together out onto the screen. You will notice now, though, that I still have not resolved this issue. Now, the group, by the way, this is not a pane for displaying things, as you can see that I'm typing. We still have to create one. So what some people would do is they would come down here, and as we've done in some of the other applications, is create the pane, name it, center it, position it, do all your stuff to it. And that's one way you can proceed. What a lot of developers also do, just to cut down on the lines of code, is they'll use a trick that I'm about to use here. So instead of creating it and then calling it by name inside of this statement, I'm going to do the opposite thing. I'm going to instantiate it on the fly directly in position. And what am I going to populate the border pane with but this group I called group. Now you see that this does require a library, so it needs a separate pane library. So I'm doing my control space trick and pulling in a border pane. Now border pane is a very interesting object inside of graphical programs because it basically divides up your screen sort of like this. You have whatever your scene is, and then it creates a top row, a bottom row, a left area, and a right area, and a center area, kind of like this. This is what it does to your screen. And you can control the size of all those and put the stuff wherever you want. And as part of border pane, you can say, I'm going to this part of the border pane, this part, or this part. If you do not designate and you just say you put it directly into the border pane, it ends up in the middle. And I'm not really too worried about which pane structure you use because you could use a number of them and accomplish the same thing. But in this situation, I'm opting to do it like this. So I'm just brute force instantiating a border pane and putting it directly into the scene and dropping the group into the center pane, just to repeat what I'm doing and why I'm doing it. But this is instantiating on the fly. So there's no name involved. It's not a named object. I'm just creating it, putting it on the screen. Brute force without naming it. One advantage of doing it this way, by the way, is because it is not a named object, it is not occupying memory space in the same way. It's creating the memory space on the fly. As soon as you close the window, the memory's gone. All right. So now that we have this placed here, and I'm noticing, did I misspell group or something? Let's see. What does this say? Oh, I see. We have to utilize the group is what it's saying. We have it in there, but we're not utilizing it. So here's how we're going to utilize the group, by the way, is I'm going to issue the group command, the named object, and then I'm going to get children. So I'm going to get multiple objects to place inside of here. So I'm going to choose this first thing, and then we're also going to issue the command add all because there's more than one. And then what I'm going to drop in here are all the rectangles and all the text descriptions as we go. So I already have 4 rectangles, and so I can kind of do this. I could just say R1, R2, R3, etc. But for right now, R1 is the only one that has been created, really, with any sort of parameters. So I don't want to put these on the screen yet because they don't have a size or shape. They do have a color, but no size or shape, so who knows what would happen. So I'm just putting the first one in, and then as I create all the additional objects, I will add them into those parentheses, and they will appear on the screen. So I'm going to go ahead and save at this point. I'm still getting a red flag here, which makes me a little uneasy. I'm not
Do you also need an equal sign on line 29?
Ah, thank you, Cody. See, I'd say that you get extra credit for that, but that's something I would have figured out in just about 2 seconds. Thank you for catching it. All right. All right, so here we go. I'm saving my work, and we are going to go ahead and launch. And let's see what happens. All right, not the prettiest thing in the world, but you can tell, once again, keep in mind that we are using what we call a border pane, so the screen is kind of divided automatically like this. Remember that shape I was drawing, so there's like a right and a left, and then ultimately, where did this box go? It went in the middle of the center box. That's what's happening. Now, is it, here's the question, 20% of the height? Well, I don't know. So let's try adjusting this window a little bit and see if anything happens. And see, it's relative to the height I've created. So it's not adjusting to the window here. It's relative to the height of the pre-created height I've determined. It is possible, by the way, by changing this parameter from a hard-coded number to a what we call a probe of the window. In other words, it detects how big the window is and then adjusts it. And I can show you how to do that. For right now, hard-coded works perfectly. All right, so that's proof of concept that we can create a box. Now let's create the others. All right, so now that we have a roadmap for how to do it, we can now do the rest. So this second rectangle, if we look at the drawing, okay, this one started 10 pixels in, and we counted 100 pixels across, so the right edge of this is at 110 on the x-axis. We add 10 more, so the next one starts at 120. So we know the first variable here is going to start at 120. It would be my guess. And actually, now that I'm looking at my other code, it looks like I was putting 20 pixels in between. So I'm going to go 130 on it. So I'm just going to follow what I did last time. So I was determining if there's 130 pixels as the starting point. Now, this height is also going to be automatically determined. We're using the same basic formula, but we're going to adjust this value to match the 10% that is appropriate for quizzes. And then we're also going to determine what the width of the object is. We already know 100. And then the height, hey, that's going to be pretty easy too, because that's also going to be set to match that percentage, which is 10%. So we're just going to change that 0.2 to 0.1. And so now once you see this, folks, right, so now I can throw this in, by the way, and I can type R2, save my work, run the program again, and I can check it one square at a time as I add it. And this is kind of the beauty of doing this type of work. So if you proceed very systematically, you can check every time you create an object. Did it work out? It worked, right? All right, so let's keep moving with that progress. And at this point, I think we're pretty confident that we can probably copy this whole line, paste it into both of these, and then adjust. So if I added 120 here, what's my next number here?
Hmm. 250?
250 is an excellent guess. That's exactly what I have in my sample code. And then these will change to what?
0.3.
Right. To match the midterm percentage of 30. So both of these will change to 0.3. Then if that's 0.3, then we know this one's going to be 0.4 because the final is 40%. And so what's this final x value going to be? And we're really adding 120, so add 120 to this, and, well,
370.
Yeah, so people are saying 370. My thing says 380. So actually the factor is a little bit different. I might not be determining my math correctly. You know what, Cody? Let's see what 370 looks like. Knowing that it's going to be a little off, by the way. But it's good to test it, right? All right, so let's see what the result of this is. Oh, it didn't show. Why didn't it show? Because I'm only asking it to display those two. So I have to add these to this statement in order for them to display. Now let's run it again. And now you can see. And now, Cody, you're going to say, that looks fine to me.
It does.
It does look fine, doesn't it? Yeah, it looks perfect. Okay, so I think we did a good job figuring that out. And if there is a difference, I'm not spotting it. So that was the right calculation. But there's our relative bar chart heights. Now the next task is to add the text. All right, so let's talk about how we're going to do that. For me, in order to kind of stay kind of systematic with this, and this is a preference, mind you, is normally I would create a text object to put the text into. So that's what I'm going to do. I'm going to call the text class, let it underline, control space, and then let's add our Java effects scene text. And then we are going to create text objects just like we did rectangle objects to take the text that labels each one. And so I'm going to follow the same naming convention. I used R for rectangle. I'm going to use T for text and create T1. And we're going to instantiate this time I didn't forget the equal sign, a new text object with parentheses. And now, once again, like we did for the rectangle, what stuff can possibly go inside those parentheses? Well, let's hover and let's press F2 and pull up the Java docs, and let's go ahead and just open it up in a tab and figure out how we're going to do it. Empty, well, no, we want to put words in there. Well, here's a version with words. Okay, so that's easy to get the words in. But then notice this third option, this overload, allows us to put in the X and the Y position, which I think will be very helpful here. And in fact, we can use the same math we did for the rectangles to help place the text, because you'll notice that these are all placed relative to the height of each bar, right? And so if you think about the only difference really being the starting point is the same as every rectangle, but the position on the y-axis is slightly less, right? Because if this is 0 and it increases y going this way, then this is probably at least 10 pixels less in y position than otherwise. So this is going to actually be pretty easy, I think. In fact, watch the technique here. Once you get the positioning right for the rectangle, this positioning is a piece of cake. And in fact, I can just copy the rectangle position, paste it in, and then right here for the Y position. And yes, I know it's throwing errors. because this part is not text. This is supposed to be text, so here, that will stop the error. So whatever the rectangle ended up being as the Y starting point, we will subtract 10 pixels. And we'll just do it right in the parameter. We don't have to, like, save it in a variable or anything. We just do the math on the fly. I can just subtract right there in position. I also see that the text for the first one should say project 20%. So this will position it, the X position, the Y position as the result of math, and then the text that will be displayed. Now this is a new object, so in order for us to see it on the screen, that T1 has to be put down here. Now this is kind of interesting because I have the habit of kind of putting it in order as it displays on the screen. That's just me. But it actually doesn't matter where you put it because it will display in the right spot anyhow because it's graphical. So this is kind of like where some of this programming kind of breaks out of that sequential top-down step-by-step thing. And because we're putting it wherever, it doesn't matter when you do it. But my habit is still to put it in order. That way they're together in the parameter list. All right, let's go ahead and save this and run it. And let's just make sure that it worked. And so if this comes out well, then we have our roadmap for all the rest. All right, so the rest of these are going to be a real piece of cake. In fact, I'm just going to go ahead and preemptively add T2, T3, and T4, even though they don't pre-exist. And then I'm going to copy this text object that I've created and then add it above each one of the rectangles. So they're grouped together. And I'm going to just rename it to T2. I'm going to copy the X position from the rectangle, the multiplier from the rectangle, and we're still subtracting 10, and then we're just going to update this part. So this now will become quiz, 10%, and then we make sure our multipliers are right, and that looks good. Let's copy to the next one. And this is all about, recognizing where it's repetitive, folks, and then being systematic about proceeding. And, you might forget to adjust one of the parameters, and then you'll see it be in the wrong side of the screen or something like that. And then you can go in and fix it. But having kind of the forethought of it helps a lot, too. This one will be T4. Here we're multiplying by 0.4. And we're just changing the text. All right, so now let's be brave and give this a try. And hopefully it works. So make saving, and now I am running. And then ultimately, when you're all done, it should look kind of like this. And you see how it all kind of fell into place real nicely without too many issues. So once again, let's just I'll leave this up on the screen here, and then I'm just going to do a really kind of quick scroll through the code. So like people watching the video, trying to get all the code all at once. Well, this is a majority of it, but here's the top half of the code through line 28. And here's the bottom half of the code and the program running. One thing that was pointed out to me by one of our students in class here is I was working off the 10th edition of the book as I created this video. And in the 11th edition of the book, the program is described like this. So it's basically the same exercise, but they're using, notice, different labels and different percentages, but the execution is basically the same. And some of you will decide that these values might be hard-coded relative to what you're doing, just so you're aware of that. All right, folks, we're now going to continue on to the other even-numbered exercise here, which is exercise 1418. And this is one of those that, once again, the author does provide the solution, but some people have a hard time getting to it. And then even so, sometimes we'll just have a hard time figuring out how to implement it. And so this video is a lot about kind of implementing this more than anything. The difficult part of the code, which is the creation of this curved line on a Cartesian coordinate system, which indicates what we call the square function. So anytime you plot a function on a graph and it has either an x...
Share your screen.
Oh, I'm sorry. Yes, I will share my screen, although the video is picking it up just fine, by the way. Thank you, Javier. But this particular curve here is generated by what we call the square function, x squared. And then you just keep pumping in different values, and this is how it would plot out. When we're plotting linear formulas, in other words, formulas that don't have exponents or square roots or cube roots or anything like that, they'll always plot as a straight line on a graph. Now, creating this kind of a shape without knowing what the mathematical formulas are or the tools available within Java can be kind of tricky, like if you're trying to code it from scratch. However, they do have tools built right into the libraries of Java that are designed to create these types of shapes automatically. And in this case, they give us the code verbatim on what you need to do to create this curved line. You don't have to figure it out or code it or follow any, crazy tutorials you find out on like Stack Overflow or something. Here is the code. And so what we're going to do is we're going to copy that code and just drop it into our application. But let's first begin by creating the new application to begin with. So in the second set of chapter 14 exercises here, I am going to create a new class file. This is going to be exercise 1418. Of course, we're adding the main method. And then we are going to extend the application class, add our library, hover, and add our start method. And I'm hoping this is becoming a little bit routine for you guys now. I'm moving my main method to the bottom, which I normally do, and getting rid of that extra space at the top. All right. Next thing I'm going to do is, I'm going to go copy that code. Let's get that right from the book. So I have it already highlighted. I'm just going to right-click it and copy. For those of you that are in my class currently, I'm going to go to my code share link, and I'll just paste it in. And here is, by the way, the code share link, and those of you in the Zoom session will get this.
Thank you.
Here's the code share link, and then when you go into the code share, I will paste in the code. So I'm going to come over here and copy it. And now it is in the code share. And just for those of you watching the video, this is the code share website that I share with my class. So this is a live interactive environment. You can just come in here, highlight the code, copy, paste it into your own. Yeah, but please leave it there for others to copy too. All right, so I'm going to go back over to Eclipse now, and I'm going to add that code right to the start method. I'm just going to kind of put it near the top, but not at the top. All right. This will, of course, flag because we do have some classes that need to be added. So the first one is the polyline class. Just make sure it's the JavaFX version. And then also the observable list object, which is one of the tools. It's a form of an array, really, is the way I think of it. And those of you that have had Python will recognize that terminology for list. Now I am going to indent my for loop a little bit so it kind of looks, more like the book, right? But there it is, in code, the code that was pre-provided for us. Now let's go ahead and save our work so far. And now we're going to go ahead and borrow from our previous application the stage, the scene, and all of that. Let's get that in place so we can display things. Oops, I didn't need to switch screens there, just tabs. And I'm going to add that right at the bottom of my start method here. I'm going to change the title straight away. And then I'm going to think about the shape of the output window. Yeah, it looks a little bit wider than tall, but generally about square. And that's what I'm picking up from that. Now I'm checking my cheat sheet to see what size I set it for last time. And what I decided last time was that 400 by 250 seemed about right the last time I did this. Now we also need to create something here to display our work. Now there's two different ways that we can do this, right? So one way that we've learned is we can create a pane class like this, name it pane or whatever you want to call it, say new, say pane again, and do the constructor, right? And then we just learned in the previous exercise, and then of course you have to do this, that you can also brute force instantiate, and that's what I'm going to do here again. I'm just going to brute force it right into this position, and then I'm going to remove that declaration. And neither one of these is right and wrong. I just want to demonstrate both techniques. All right. This does require a library, so let's make sure we add it. And now we don't have to worry about creating that object here. Now, one disadvantage of doing this, and I just want to show you this, is remember in this application how we were getting children and adding all, and we kind of had a spot to do it. All right, so now how do I do that with this setup? Well, that becomes the challenge then, because now we have to feed those objects directly in here, but then we also have to issue all those same directives. So guess what, folks? This approach is not really going to work, but let's do it like this. Let's go back to this version, because this allows us to add the children correctly. And so hopefully that roundabout explanation helped you, but if it confused you, I apologize. I didn't mean to do that. Ultimately, we will have a statement here, and I'm just going to pre-build it so it's ready, where we are going to get children, and then we are going to add multiple objects, so we're going to say add all, and then as we create the objects, we're going to drop them inside of these parentheses here, one by one. Right off the bat, we have something we can display, because the polyline is something that creates a visual element on the screen. So I can pre-add that straight away by name. And in fact, I can run this now and actually take a look. And I'm noticing I put the pane up here. Oops, I didn't want to do that. I really don't want it to be global. I do want it to be inside the start method. So I apologize for that. Let's fix that. All right, and I'll give you guys a second to catch up. And then I'm going to go ahead and launch this and see if the polyline even works. And I see that I have one problem here. And I hear somebody's mic come on. What are you guys going to point out that I did wrong?
Your main method.
Ah, what did I do? Thank you, Cody. Cody, you're like my built-in debugger. Thank you, sir.
Mm-hmm.
All right. So if that happens to you too, and you're like, come on, let's go, and nothing's happening, and don't delete your curly brackets, by the way. All right, let's try that again. Save and run. And we should, voila, have a polyline. Wait, it's upside down. All right. Now, this is known errata in the book, by the way. But I kind of show this, and I'm curious. I know some of you are working off the 11th edition. I have the 10th edition on my screen. Do they change any of this stuff here in the 11th edition?
Nope, I don't think so. It looks, yeah, it looks the same.
Okay.
It looks the same to me.
Okay. If we needed to fix this, though, how would we flip this to go the other way?
Oh, you know, in the 11th edition, they actually do x times x times x. If I'm not mistaken, they have an extra x on the end when they have the list.add scale factor.
Okay, so right here, right? They're going x
Right.
times x times x?
The 11th edition only has 2 X's.
Interesting. You guys might have different versions of the same book. Now, I'll tell you what my fix for this is, by the way, is I just did some simple math because I looked at x, which is plus 200, so that's kind of the scale under which it's traveling. And I just put the 200 in front of this equation. And you don't necessarily have to, understand the math on this, but this is how you make it flip the other way. One way you can do it. I'm just inverting everything. So I'm going to save this, and I'll show you how it looks. And if you just follow along with my example, that's fine, because that looks a lot more like what the book has, right? Now, I have people that struggle with this, and another fix for it is to actually change the sign right here, I believe. That would also do it. So, anyhow, I would say follow the way that I'm doing it. Put a 200 and then subtract all the rest of it from there, and it should work out okay. And if it doesn't, we'll take a look in the aftermath. But for right now, we do have a polyline that's working and looks like the book. Now,
I'm just getting an empty window.
okay, well, you know what? Make sure that if you're getting an empty window, that you make sure that you added the polyline here.
Oh, yep, I didn't do that part. Sorry.
Yeah, that's probably what it is. It was almost as bad as me forgetting to launch.
Well, I mean, it happens, and then I'm like, oh my god, did I really just do that?
Yep. All right, so let's move on to the last part, which is now we just really have to create all of the other pieces. And I'm trying to get the book on the screen here. So we're just going to be creating the lines and the labels and the arrows. And we're going to do that all manually. And for those of you that have done the Hangman thing already, if you looked at that video, you can follow all the techniques I use to do it. But I'm going to kind of do this very systematically, one line at a time. And I'm trying to do it in kind of a quick fashion for the sake of being able to maybe get to another exercise tonight. And so I'm going to do a little bit of copy pasting and then explaining rather than typing it all manually. The first thing that we're going to do is we are going to create the line class here in order to be able to display a line. Of course, we don't have the library yet, so we control space and pull in the correct JavaFX library. From there, I'm going to decide to label my lines. I guess I'm going to go line 1, line 2, etc. And then I'm going to create a new instance of line and close it. Now, we should check the parameters for this. What are the overloads? And I'm just kind of scrolling down here, and it doesn't tell me enough from this view. So once again, I'm going to hover. I'm going to F2 it to bring up the Java doc, and then bring it up in a tab. That's my preference. You can do it any way you want. But you notice that you can do it plain. You can have a starting XY and an ending XY, which sounds pretty logical to me. So let's use that approach. So start XY, end XY. I think it's pretty simple to remember. And so where are we going to start? Well, I guess it kind of depends on where the polyline is. Well, part of the polyline, given the way this equation works, is going to be relative to 0. So it's going to intersect 0 at some point. The question is, where is it actually putting that? And we have to make some speculations relative to the window size, but some of it is also relative to how this tool works. So I have a little bit of an insight on it, and I wouldn't expect you to know this because you would actually have to research the tool. It would tell you where it places it relative to everything else, and then you would understand why you have this. But I'm not worried about that aspect of it, because if you were doing this professionally, you would totally research it and know it. For right now, we're just trying to get it on the screen and have it work, so I'm sharing the code with you outright. The first line I'm going to create is going to have these parameters. And remember, this is start XY, end xy. So we're going to start at 10. So if you can picture this on the screen, at 10x, so this is the line we're creating. And the y position, whatever I determine that to be, is going to be relative from the top, and we're choosing 200. From there, the ending xy, we're going to move 390 pixels over, but the y is going to stay the same. It's a horizontal line. All right, let's save this and run it. And of course, miraculously, it's going to perfectly line up with the poly thing, except I forgot to do one thing. And what's that, Jay?
It right there next to the polyline.
Yeah, I gotta add it to the object here. All right, now let's run it. And I guarantee you guys will do that a dozen times yourselves. Now, of course, I have the magic code where I know it lines up. But if you did this and you didn't know where it was going to line up, you would just speculate on the y and then move it until it matches. That would be the one approach. All right, let's move on and create the next line. And so I'm going to start popping these in one at a time now. And I didn't want to put it there. I apologize. I want to put it here. So this is our second one. And you can tell from this one, because the X position is fixed, that this is the vertical line. Just from that little tidbit, you can tell that. Let's run it again. And although it's kind of cumbersome to run it every time you add something, that's the way you validate it. Once again, if it was off, you would move it a little bit. All right, and then we're just going to keep adding. And for the rest of these, folks, here's what I'm going to do, is I'm going to be dropping all the rest of the code. The same stuff I'm going to paste into my window here is going into CodeShare, by the way. Replacing, well, I guess not replacing, adding to what's already there. All right, you guys don't waste any time. Yes, and then paste that into your code. This is one of the advantages of coming to class, by the way. So I'm just going to replace all of this. So I'm adding 6 lines and then a couple snippets of text. The text library is required, so we have to hover and grab that. And then you also have to remember to add all the objects to this statement. So line 1, line 2, line 3, line 4, line 5, line 6, and let's see, we got text 1 and text 2. All right. Once you have all of that in there, folks, it should be good. And hopefully we get the beautiful and perfect looking little polyline that's just like the book. And now this is kind of a cumbersome way to create graphics, really, but it is important to note that Java does have a lot of libraries, like the polyline library that's pre-built to do complicated mathematical plotting. And this is just at the tip of the iceberg of what's out there in Java libraries. Unfortunately, we don't have the kind of time in class to go into all those libraries, but if you were in a professional situation where you were coding, you would probably delve into specific ones as the need would require, and you would study them, very much by just going to like the Java docs, typically, pulling them up, getting them in that browser, and reading about it, and then probably going out online to see examples of how it's done. And this will kind of break it down, and you see how it even goes deeper. But the Java docs here usually always drop right to the constructor area on how you build it, what parameters you can pass, and what it basically does. All right, but that's the value of that. And if you guys don't remember that from the first Java course, or maybe it wasn't like emphasized enough, when you get to this level of Java programming, there's no, like I said, no way you can remember all this stuff. It just doesn't happen that way. So this is exercise 1418. All right. Once again, let's get a whole screenshot of the whole thing. I see that we have one unused library here. You guys notice that? is never used. So what do you do with a library that's never used? You delete it. You don't need to call in tools that you're not using. All right, here's the top 28 lines. And then I'm going to scroll, and there's the bottom of the code. So you have all the code if you're watching the video and screenshotting and pausing. And then the trick is to actually make it work, which sometimes is more of a challenge than just copying the code. All right, we're going to move on now and try to hit one of the other exercises before we wrap up here. We got another 27 minutes, and I want to utilize that fully, but let me do this first. All right, we're going to move now backwards to exercise 1417 to complete the Hangman exercise, or at least get a good solid start on it. All right, so what we're trying to create here is basically this graphic, and the instructions are: write a program that displays a drawing for a popular Hangman game as shown. Okay, well, all right, let's get started. They don't really give us any other instructions aside from that, so we're going to do a lot of speculating here as to what might be the correct way to do it. But we'll begin with all the standard application creation steps. So let's go ahead and create a new class. Let's name it exercise 1417, and we'll add our main method. And this time I will forget not to not include this. That's a double negative, I guess, because last time I did, and I was wondering why nothing was happening. And then we will extend the application class like we always do for JavaFX, add the library, and then hover and add the start method. I'm going to move my main method down as I always do. Get it out of the way. And then I'm also going to go back to one of my previous applications and grab this apparatus, the scene and the stage basically, and put it at the bottom of my start method as kind of a starting point here. All right. I am doing a little bit of cheating here, and I'm looking at what parameters I used last time for the size and shape of the window just to save us a little time. And what I did is I chose a workspace of 500 by 500 pixels, a nice square. And I used the same technique that I did before to create the visual aspect, which was the grouping technique, while some of you guys used a pane. And just to kind of mix it up a little bit, I'm not going to use the grouping this time like I did in the previous video. I'm actually going to just use a pane command. So I'm just going to create a generic pane class, add the library. I'm just going to call it pane since the variable is already set down here. And let's go ahead and instantiate that new pane, like so. All right, so now we have somewhere to put stuff. To also prepare to receive things, I'm probably going to write a whole bunch of code in here to create all the objects I need, the shapes. And then right before the scene renders, I'll have a little command that's just going to say pane.getChildren.add all, since we know it's going to be more than one object. And then whatever we create, it's going to fall in the parameter list here. And as we create each object, we'll just drop it in. So our structure is built, and all we have to do is make the objects that will get added here for them to display here. I guess we may as well fix this. Let's call it Hangman. All right. The one thing that I do want to talk about as we create this, so we're creating this silly little thing, and it is kind of silly, but at the same time, because it's silly, it's fun, right? But I want you to think about the fact that if you wanted to actually create like a Hangman game, like an application, you could create a graphical application that had the pre-built, noose and everything for the guy, and then you could have it ask questions like, guess a letter, and if they guess wrong, you could start adding the objects on the screen. So you could totally write code for this, and I hope you guys can kind of see that as we're doing it. All we're doing is creating the visual, but it wouldn't be that much more to actually create the additional code that would allow this to become a full-blown game if you were so inclined. This is kind of the starting point. The other thing is we are learning to draw using code. And the other question that people would have is, oh, well, Ty, we're drawing lines and stuff. Could I, we put in pictures of cards and X's and O's and flags. Could I have a picture of like a real person here? Yeah, you totally could, right? So you could actually have them, add arms and legs of a real image and figure out where to place them. That's another thing you could totally do, just for ideas, mind you. But let's go ahead and start creating these objects one at a time. And the way that I look at that screen is I look first, and I guess I should probably keep this very handy. In fact, why don't I screenshot this and I can just pull up the snipping tool rather than pulling up the whole darn thing. So this is kind of what I'm looking to create right there. Okay, and I can keep referring back to it. And I'm keeping this kind of on my second screen, just off to the side, so I can always see it. And the first thing I'm looking at creating is what I would think is whatever's the easiest thing first. That's how my mind works. And for me, the easiest thing is probably either this vertical line or this horizontal line. And I think in my mind, it's probably easier to start with, I don't know, I think I'm going to go with the horizontal line first because it's at the top. Hey, why not, right? All right, so let's move this over. And I'm just going to come down here, and I know I need to create a line. So I'm going to call the line class and bring in the library. We can call that line 1, or if you want to get more, descriptive, totally up to you. I'm just going to say new line. And then we learned from the last application that we did that when we use the line class, one of the sets of parameters we can feed it are the starting XY and the ending XY. And when I look at that graphic, I'm thinking that this screen, if this is 500 across, ballpark, how many pixels down is this? And I'm going to guess 20. So the starting and ending X will both be 20. It's just where the starting and ending Y's are. Now, it's not all the way at 0. And actually, I'm saying this backwards, aren't I? Right? The X is going to be the same all the way across, and the Y's are... Did I just say that? No, the Y's are going to be the same all the way across, right? So this is not changing its vertical height. The X's are changing. So starting X and ending X are changing values. Clearly, the ending X isn't all the way at 500, and the starting one's not all the way at 0. So now we're left speculating. And I'm just going to make basically an educated guess on this. And so I'm going to say this. Let's go 20 pixels down from the top for Y, and I'm going to start with 150 pixels over from the left for X. Excuse me, Y. See, I'm doing this backwards again. So this is my X, right? This is the X. This is the Y. Now, I know that in this circumstance, I'm not going to be changing that X. And see, now I want to do this backwards. I am just... I apologize, folks, if you guys are trying to type along with me. That Y, okay, the Y is not going to change. See, I'm talking myself through this. This is very silly. All right, let's go 150X, 20Y. Now, we know the Y is not going to change in the final parameter, so I can just pre-type that. Now, the question is, how far across is that line going? And if this is 150, my temptation would be to have it 150 from the edge. So that would be what? 350, but then I need to have a little room for the arms because he's kind of got like some long arms here. So maybe I'll make that like 300 is my kind of guess here. So let's do that. Let's call this one 300. All right. I'm feeling very uneasy about this because I'm kind of confusing my X's and Y's. Let's just get this on the screen and see what we got. And this is kind of the beauty of this programming too, is you can see it. So let's bring it up on screen, and there's my crossbar. You know what? I could have gone 350 or something, but you know what? Let's just go with this. This will work. If I need to make it longer, all right, I'll make it longer. All right, so that's the first line. So now I'm going to create the second line. Of course, it's just going to be a lot of lines here. So let's just copy paste. We'll call this line 2. And now we're going to adjust a little bit. So we're going to look at that drawing again. And if we started up here at 150x and 20y, the dropping line will start at the same point. So the xy to start with will be the same. I don't have to change these. Starting xy is still the same. It's the ending xy that's going to change. Now, in this circumstance, the x isn't going to change and the y will. So this will be, 150. And now the y will change. Now the question is, how far am I dropping? If this is 0 and that's 500, this might be like, I don't know, 400, right? So that's what I'm going to put in there to start with. So let's put in 400 in this spot. Save it. Let's add the other line to this statement so we can see it. And let's be brave, save it, and run it right away and make sure that we are forming the shape that we want. And that looks pretty good. And one of the tricks there was recognizing that they have a shared starting point. One question I get often from people is, you know, Ty, could I put this value in down here as the starting xy and this one as the ending? Sure, why not? There's no rule as to which order they have to be in. As long as it goes from one point to another, it'll still get there. That's, I think, an important one to know. Now, I'm still kind of hell-bent here, real frankly, on doing the easy parts first. And so the only other easy thing that I see here is this. I see that there's a straight line here leading to his head. Now, you can kind of take this a few different ways. So some people will recognize, well, actually, this is kind of a straight line that extends all the way down to here, you know, basically down to where his legs start. And then I could put the circle over it, fill it with white, and nobody would even know there's a line behind it. So that's totally a way to do it too. So in fact, I think I'm going to do it exactly like that. So I'm going to create another line. I'm looking for efficiencies here, folks, you know, as when I do this kind of stuff. So we'll call it line 3. And now, instead of using this starting point for that line, we're going to use this point up here as the starting point. So the ending point for the first line is the starting point for the third one. So the ending point for the first line is the starting point for the third one. So I say that so I don't forget it, by the way. Now, we know that the x isn't going to change because it's a vertical line. So it's going to stay at 300 because it's going straight up and down. But we know the y will change. And one thing I know for sure is that this, you know, where the legs start, is ending much sooner than the 400 down here. So I'm going to speculate it's not like halfway. 200 would be here. So I'm going to call it like 220 or something like that. I'm getting rid of these. So this number is going to become 220. Let's save it. Once again, let's add the line here and let's run it. Save our work. And okay, maybe you're not seeing it quite yet, but like I said, I'm going to put a circle over the line so you don't see it. And then I'm going to build my arms and legs off of here. All right. So I think for now, I think all the easy, super easy stuff is done. Probably the next challenging thing is to figure out the head. So for that, we clearly need to make a circle. And so the next line of code that I'm going to write here, I'm just going to say circle. Of course, that requires a class. So control space to get the shape. And I'm just going to call this one head, because that's what it is. And then I'm going to issue the new circle like so. Now, of course, there are parameters for circle. Let's hover. Let's scroll, see what they might be. Well, that doesn't tell me much. So let's go to the Java doc. And one way that we can do a circle is like this. So we can do a blank one. We can just have a center X, Y, and a radius. Well, that's kind of nice. But how about this one? The center X, Y, the radius, and a fill color. Now we're talking, right? So this is the approach I'm going to use. 4 parameters, center X, Y, radius, and fill. All right. So now what is our center X going to be? Well, it's going to be the same as the line that we just drew. So that's a given. That's 300, piece of cake. All right. But the center Y, now we have to do a little bit of looking here. So if this is already 20 pixels down, and this is at 220, we have to speculate as to what the center Y position is going to be. And you know what? If this is 220, half of that would be 110. I don't know. I'm like very much speculating here. I'm just going to say 70. Yes, I'm cheating though. All right, so 70 is what I put in last time. So that's my center Y. Next, we need to have a radius for the circle. And so if this is 20 pixels, it seems to me that a radius of the circle of about 20 pixels would, thanks Cody, would be about appropriate. So I'm going to put in a radius of 20, so that's my next parameter. And then finally, I'm going to put in the fill color. Now, in the example, the fill color is white. Okay, so you could do that, you know. And so I'm just going to type in a color, and then I'm just going to type in white. Now, some people will notice here that, okay, well, if you put a fill color over it, that's wonderful. You know, in fact, let's take a look at this, and I want you to see what the result of this is before we press on. So this is called head, so we're going to include head here. Let's run this and check this out. You're going to go, wait a second. I can tell the circle's there because it's covering the line, right? But I don't see it, which is kind of a little bit of a problem. Because
it's a border.
Yeah, right. And see, unfortunately, there's no parameter when creating a circle to also add what we call the border or the stroke. That's what it's called in graphics. So I have to do that in a separate line. So I'm going to say set stroke, and we're going to just say color black to match up with everything else. Now, there are also commands, by the way, where you can determine how thick it is and if it's dotted or dashed, you know, just like in CSS, but we're sticking with simple stuff right now. And now we're going to save this, run it again, and now notice that we can see the circle. Yay! Okay.
Ta-da.
Yeah, very, very good. Now we're left with a couple more pieces to finish. And you know what? Maybe it's time to tackle the arms and the legs. Now, the beautiful thing about the arms and the legs is this. We can do a lot of different stuff with them and just kind of guess. Like, for example, and this is, you know, the little conundrums you guys will face, is, all right, I totally see, you know, how you got all this stuff and everything lined up along this line to get that 300. But when the arms and the legs, well, I guess both of the legs are starting at the same point, so that's right along that 300x line. But the arms seem to be starting at the edge of the circle. Now, wait a second. Do I have to calculate, you know, like 2 pi r and do all this like math to figure out where it starts on the edge of the circle? No. It's not how we're going to do it. We're going to be more clever than that. We're going to actually do this. We're just going to actually create the lines so that they actually go all the way to that bar, because we know where that bar is at 300, and let the circle obscure it, because that'll just be the easiest thing. And then we can just come up with a starting and ending point and then mirror it on the other side by doing simple math. Okay, that's my attack strategy here. So watch how I do this. All right, we are going to create another line, so I'm just going to grab the line code, paste it in, call it line 4, and we know right away, like because I said, right, we're going to start at 300. That's going to be the starting X. It's kind of a given. But we don't want to start all the way at the top. We want to come down a way. We already know that this is 220. This is 20. How about in between? Maybe the place to start here is at around 120 pixels. I'm just speculating based on my cheat sheet. Once again, just to save time. If you're doing this from scratch, of course, what you're going to run into is a little bit of an issue figuring out where these points are, and frankly, it's not really a big deal to, like, in a sense, screw it up and then just have to adjust it. Okay, so that's the starting point. Now, what about the ending point? If I'm going from the 300 line and then taking my Y at 120, okay, so I'm just going to do a visual here because this really helps a lot. This is 300X going up and down. 120Y, I'm speculating, is somewhere around here, right? And so that's the starting point of the line. Now I want to draw this line on an angle from this 300 120 position down to whatever this is. Now the X will diminish, right? And since we know this line is at 150, maybe this one ends at, I don't know, 250. So this parameter, that X, I'm going to speculate is 250. Then what is the Y for that? If this is 120 up here and this is 220 here, I can probably guess somewhere in between that would be around 170 for the third parameter. And I'm not sure what it's going to look like, but we're just going to go ahead and add it and then see what happens. Okay. Of course, I do have the cheat sheet, so I know this is going to work. But if you didn't, you would be guessing. Now you notice I also made a choice. I thought the author's, arms don't come out of your head. Sorry, they just don't.
I was thinking that too.
I was thinking the same thing.
Most
Are
people.
we gonna give this poor guy a neck, or?
Yeah, in fact, we could even give him an Adam's apple if we wanted, right? Or an ears if you want to draw in some ears, right? Because that's how Hangman goes, right? You do like head, arm, legs, torso, and then you're drawing in fingers and toes.
Just to give the other person a chance.
Exactly. All right, so now we're going to take this line and mirror it. So we know the starting point's going to be the same, and then the ending XY are going to be a flip. So whatever the difference is from this line to that line, we'll just flip the numbers, and you'll see how we do that here. So we're going to create another line. Starting point's going to be the same, ending point's going to be different. So if this is, this X is 50 off from the original X, it's going to be 50 off of it in the other direction, which would make this number what? 350. Now, in terms of the Y, will it end up in the same spot? Well, yeah, because you want the arms to hang down to the same position. Our work is already done. So let's see how easy that is now that we had the first line. So we'll go line 5. Let's add that one and take a look. Hey, we have arms. Yay. All right, so now we'll do legs, and you know what? The legs really can, if you look at their thing, they can kind of be the same. In fact, I'm going to put them on the same angle and make them the same length. I'm just going to move them down. So if I'm moving them down, which parameter am I changing? I'll be changing. And so the legs will start at 220 for both of them, and then they will end, I guess 100 pixels farther down from where they start. So this will just become 270. All right, so now we're going to add 2 more. Yep. So I'm going to, oh, hey, it came back. Yay. All right, so, hey, just when I was about to give up, and then you can see my mouse is trying to catch up with all the movements that I made before. Very fascinating. It's being very, very sluggish. So I'm just letting it do its thing right now. And what I'm trying to do is optimize memory in the background by closing just about everything I have open. All right. I think we're okay. All right, so let's go ahead and run this. I just want to make sure that it worked. And did we add the legs? No, we ended at that point. So we're going to add line 6 and line 7. And and if anything, you guys, what that was a really good lesson in is sometimes don't give up and like shut down and reboot and stuff. Sometimes it will recover. So don't necessarily give up. All right, so there it is with legs. The last thing we have to make is the arc, and the arc is the trickiest of all the pieces. And sometimes I get students that, even though they look at the examples in the book, kind of freak out to that one a little bit. But let's show you that it's actually pretty darn simple. I'm going to just brute force drop this in, and you guys can just copy paste it or type it in really quick. We do need a class for the arc. And the way that the arc class works, I think it's center, there we go, it said it right there. Center XY, radius XY, so there's a different radius for X and Y positions, the start angle, and the length. And so that's the command to create the shape that you see. And then I'm going to augment it by filling the base with white and also setting a stroke so you can see it, because like a circle it would not show unless you did this. And then finally all we have to do is add that arc to the screen and run it. And what I'll do here is just show you what I have. So it's not like the most beautiful thing, but I did basically accomplish it with my own style, and it's okay that yours doesn't look exactly like the book. The point of it is really to kind of figure out how it works, how you move stuff around, how to see it, how to adjust it, how to do the the calculations to figure it out. That's really the exercise we're doing here. All right, so I'm going to stop this video here and then I'll field questions.